Hello, my name is Richard Nicholson, and this is the first in a series of videos concerning the Paremus Service Fabric. The Paremus Service Fabric is a distributed runtime which is dynamically formed from a population of fibres. Each fibre is in turn an OSGI agent which is capable of assembling and hosting a modular OSGI application or deploying, configuring and controlling a more traditional software artifact, for example, an image deployed to a container. In this example, and usually fibers are created by Atlas. Atlas agents are lightweight native processes which will run on your physical, virtual or container resource. And those provide a description of the resource they're on, which is discoverable via the Atlas Manager in the runtime environment. And the idea is that the Atlas Manager discovers available resourcing and matches that to the requirements of the fabric we're trying to create. So in the example on the right-hand side of the screen, we have a fabric called Service Fabric 1. And this requires two sets of resources. It requires machine resources which are red and machine resources which are blue. And the Atlas process allows us to dynamically discover resources in each category, group the required number together to create that fabric. However, Atlas is optional. You can deploy fiber software to a virtual machine image or a container image and deploy it via more traditional deployment mechanisms within your data center or public cloud environments. The flexibility of the resources in the fabric are then a function of that provisioning mechanism that you use. So having described or provided an overview of a service fabric, how many are required? Do you have one very large fabric, many fabrics? Well, the answer is it depends on your business requirements and the structure of your organization. Fabric is designed to span many thousands of physical compute nodes. But it's also very lightweight, and a small fabric can be deployed within a single 4 GB virtual machine image, and it's very simple to run example service fabrics on your laptop resource. The whole idea of service fabrics is that they map to the structure of your organization. So typically you may have development, QA, stress test and production environments, and you would typically map a service fabric to each one of those. You may have a number of parallel fabrics for each business division if you're in a very large organization. You may want dedicated fabrics for particular services that are being exposed to your customers or internally. You may want to have a fabric which is a general resource for a particular business division. You can slice and dice these in any way you really see fit. And the purpose of a fabric is to be as flexible as required, and it's very easy to reallocate resources from many small fabrics to create a larger one, or split a larger fabric into smaller fabrics as the structure of your organization changes over time. Now, today we're going to use DigitalOcean, which is a cloud provider, and we can see here, if we actually search for the machines we're going to use, we have a set of about 20 machines, each of which are 2 GB of memory, located in DigitalOcean's London data center. Okay, it's a fairly standard resources that you can pick up from Amazon, Google, or wherever else. I'm actually logged into one of these machines, and I'm going to bootstrap up a fabric. So we're going to create Service Fabric 1 as per the diagram we just looked at using Atlas Manager. And it's a simple one-line command. We're going to say fabric -s for start or create, and then the name of the fabric, Service Fabric 1. Which actually specifies a profile, which specifies in turn the types of resources we need and the number of resources. So previously in the environment on these Linux machines, we installed the Atlas agent, which is a small native process running on each machine. This was actually placed on the virtual machine image we used to create each one of these machine instances. Okay, so we can see that the process has gone out and discovered a bunch of compute resources in the environment. Some of these compute resources are reporting back that they're tagged with particular attributes. So we can see we've got something tagged as an infrastructure boot node, a couple of infrastructure backup nodes here, and then the rest of them aren't allocated. This is a very generic tagging mechanism we use, so you can specify any key value type you like. And what's happening is we're starting to create an infrastructure node on Fiber 3. So this entails downloading the Fiber software to that particular compute node, unpacking and starting the OSGI runtime. While that's running, what we'll do is now jump over and look at the actual management layer assembly itself. So, okay, yes, it's actually started already, Service Fabric 1. So we'll connect into this and we can see one fiber, this is the initial infrastructure fiber, running in the environment. So what we'll do while the rest of the nodes are being configured and joining is have a brief look at what this Fiber 3.1 is. So if we click, first of all, obviously the tooltip, we can see its name, we can see CPU utilization at the moment and memory. Clicking through, we can see a number of different views for this particular OSGI framework. So the first one, the Fiber tab, gives us a generic description. It tells us the application components which are hosted by this Fiber, which aren't any at the moment. We've not deployed any applications. The key value tags that we've placed on this Fiber, there aren't any at the moment, and these will both be described in future videos in this series. Then the Fiber properties, so the boot time of the actual machine. So we actually started this machine July this year, and we've not had reason to reboot it since. Certificates that have been loaded by the Fiber as part of its bootstrapping process. The Java JVM that's being used, and some other bits and pieces of information, including the software version of the Service Fabric release that we're using. Okay. Now, we are a very service-orientated runtime environment, hence the name Service Fabric. And this tab shows us the services which are imported to and exported from this particular Fiber. So the down arrows are services that are imported to this Fiber from the external environment, i.e. from across the network. And opening this one up, we can see that we're getting a service imported, a Fiber probe, from this IP address. We can close that down. And we can see services that are being exported by this Fiber into the environment. So here we're seeing that we've got a probe being exported into the environment by the Fiber. Okay, these are what we refer to as coarse-grained services in the Service Fabric's view of the world. Most people would consider these microservices. If we click, we can actually see the service wire-up within the JVM. So if we're talking about microservices before, we're now seeing, in effect, nano-services, very fine-grained components wired together within the JVM. If we just look at the first one, we can see the package admin service, which is being registered in the JVM. And we can also see the backing bundle for this. We're at OSGI runtime environment, and by clicking on the bundle, we can see the information for this, the metadata information. Okay, let's just have a look at one more. Let's look at the bundle, and there's a little bit more metadata information for this guy. Okay, so that's a service view. The next thing is configuration view for this Fiber. So these are the properties for the installed bundles and which key values are available to be modified. To be able to modify these, I need the appropriate roles within the environment, and I actually logged into this prior to the video with effectively Fabric root, so I can do anything that I feel is appropriate. We can look, of course, at the bundles from which the environment's assembled. And we have filtering so we can find bundles that we're particularly interested in, and again we can look at the metadata for that particular bundle. We can look at the JVM, which is hosting the Fiber. So this is a JVM, and we get reported the heap, non-heap information, and also as far as the JVM is concerned, the physical environment it's in. So we're using a 1.8 JVM. And from Oracle in this case. And here's some threading information. And from the machine view, the JVM thinks that it's running on a 2.4 gigahertz Intel box with 2 cores. Obviously, that may be physical or maybe virtual. We can't tell from this view. That's the whole point of machine virtualization. We have a logging view for this particular fibre within the fabric. Okay, we've got a couple of warnings coming up as the new fibres join the environment, but nothing of any interest. And a complete alarm system as well, which will be a topic of a future video in this series. So let's go back and look at the Service Fabric view again, and we can see that during that process of looking at the initial boot fibre, all the others have now joined the environment. So we have each node is hosting 3 JVMs, each with a fibre. So in total we have about 60 OSGI frameworks that we've deployed within this environment, all working together collectively as this entity Service Fabric 1. A couple of things to point out on this front page view. We can order the fibres by type. So the infra nodes that are working at the moment are ordered first in this case, and then we have the workers. We can order them by CPU usage. So we can see that actually the infra nodes are just in the mix in terms of the CPU usage within the environment, and reasonably low. These guys are still setting up during the bootstrap process. Memory utilization. And again, the primary fibres are taking up most memory at the moment in this case. Remember that we're running in 2 gig memory machines, so quite lightweight environments. And the backups are running at quite low memory utilization. Okay. And the final thing we can do here is turn on alerting. So this tells us alerts for particular fibres on the fabric. Again, we'll go through the alerting mechanisms in a different video in this series. And if need be, we can turn on memory and CPU bars for each fibre view, which actually expands out the real estate view and can be useful, however I personally prefer to run in the more compacted mode. Okay, the whole purpose of creating a service fabric is to deploy a distributed application. If we look at the systems view, we can see that we have no applications deployed. And so we'll finish this first in the series of videos by importing and running a very simple application. So we'll do this as follows. The following is referred to as a system. So applications that run on the Service Fabric are referred to as systems. And we'll just collapse down this view so we can look at the salient points here. So a system, in this case, Hello World, consists of a system part. This is a unit that will be deployed to one of the fibres in the environment. The system part, in turn, consists of the following 3 system part elements. We have the Hello World service itself, which is an OSGI bundle in this case, declarative services based. We have the front end for this application, Hello Web, and we have the Jetty service, which is required for the front end web. We open this up, and we can see that we have a configuration on the Jetty service, which is setting the port to 8192. And if we open up the application component, we can see we have a configuration which is setting the language to be used to German in this case. Okay, now these systems can get much more sophisticated, and they're not only concerned with OSGI components. As we'll show in future videos, we can deploy software artifacts that run externally to the JVM and even run in Docker containers. Okay, but what we're going to do today is just simply import this and run it on the fabric. So I'm going to copy and paste this URL. I'm going to go back to the fabric and import this system description from the Nexus repository where it lives. Now, when we import, the Service Fabric is going through a number of processes. It's validating the document, and it's caching in all of the software artifacts that are required to run this application. So we can see that the Fabric's done a resolution, found all the software components required, and downloaded these into the runtime environment. So here's the download information. We can look at the cache view, and we can see the cached artifacts which are now available. At this point, the Fabric's completely decoupled from the external repositories. So now what I'm going to do is deploy the application. And when I deploy, what happens is the fabric is now negotiating with the population of fibers that we just created, and it's finding a fiber which is happy to host the application. So in this case, we're just deploying to one node, and we'll show scale out behavior and adaptation behaviors later in the series. But the node picked was fiber 15.1. That pulled all the software components, assembled them, and created the service that we can now see. And as you saw, that was very rapid. So finally, to see that this application is actually running, what we'll do is just find the IP address for this particular node. I'm going to go to the front end view. And here we have the hello service that we just created in this environment. And now that's running. Hello everybody. And we can just demonstrate very quickly that that is indeed the system that we created by going back and deploying it. There we go. That system is now undeployed. We go to the screen, refresh, and the service is gone. Okay, with that, we'll conclude today's first in the series, and thank you very much for watching.